Hypothalamus Artificial Intelligence Incorporated, HI. It presents to companies in the process of digital transformation, its offer of professional services and the supply of algorithms of highly complex multi-problem mathematical models. These services are called Artificial Intelligence for Decision-Making, Optimization of Port and Railway Megasystems. To provide these services, HI is supported by its business partners, GAMS, IBM, and TD SYNNEX, all producers of AI technologies. HI is a company at the forefront of high-performance artificial intelligence. The presentation is based on a proof of concept conducted by HI, with another partner from Peru's Port Authority. Design of port and railway megasystems. The growth of the port sector, driven by the growth of maritime transport, entails the execution of megaprojects aimed at the construction of sustainable port and railway systems. This is an opportunity to use operations research methodologies for regional planning, including semi-detailed port operations. These models must be integrated to quantify the impacts of port region decisions, to carry out regional planning that maximizes the well-being generated in the social surplus, and that guarantees the sustainability of development plans. El Callao, Shanghai Port System. The port of Callao, located on the central coast of Peru, is one of the most important and largest ports in South America. It is a fundamental key to Peru's economic development, serving as a vital link between the country and world trade. Some of its main features are: strategic location, located in the Callao region, a few kilometers from the capital, Lima. This port is a crucial point for Peru's international trade. Capacity and size, it is the largest port in the country and handles most of Peru's maritime trade. It has several specialized terminals, including container terminals, general cargo terminals, and bulk terminals. Specialized terminals. Multi-purpose North Dock, handles a variety of cargoes, including containers, bulk, and general cargo. Container Terminal, South Dock, specialized in container handling, operated by DP World. Mineral Terminal, dedicated to the export of minerals, one of Peru's main export products. Modern infrastructure, it has received significant investments in infrastructure and technology to improve its efficiency and capacity. It features gantry cranes, advanced terminal management systems, and large storage areas. Connectivity, it is connected to the country's land transport system, including roads and railways, facilitating the distribution of goods to the interior of Peru, and to neighboring countries. Security, implements strict security measures to protect goods and port operations, including surveillance and access control systems. Additional services, offers a range of additional services such as warehousing, cargo consolidation, customs services, and integrated logistics. Cargo handling capacity, it can handle millions of tons of cargo annually, being a key port for exports and import, and economic impact, it is an important engine for the Peruvian economy, generating employment and facilitating international trade. The Port of Shanghai. It is in Shanghai, in the province of Huaral, Department of Lima. Located on the central coast of Peru, approximately 80 kilometers north of Lima. This port is being developed with the aim of becoming an important logistics and transport hub in the region. The Port of Shanghai is a maritime infrastructure project located on the central coast of Peru, approximately 80 kilometers north of Lima. This port is being developed with the aim of becoming an important logistics and transport hub in the region. Below are some of its key features. Strategic location. Modern infrastructure. Capacity and technology. Investment and development. Connectivity. Economic and social impact, and sustainability and environment. The Port of Shanghai is projected as a high-capacity infrastructure. According to initial plans, it will have several docks to serve different types of cargo and ships. The most recent specifications indicate that the port will have 4 multi-purpose loading docks, designed to handle containers and bulk cargo, equipped with cranes and advanced technology for efficient cargo handling. 2. Additional mooring areas. Possible additional docks for specialized cargo or future expansion. complementary infrastructure for logistics operations. These docks will be distributed to optimize the handling of different types of cargo and improve the operational efficiency of the port. With the development of all its phases, it is expected that the port of Shanghai will become an important logistics hub in the South Pacific, facilitating international trade and improving Peru's competitiveness in the global market. El Callao, Shanghai Port and Rail Megasystem. It seeks to optimize the operations of the ports of El Callao and Shanghai, to improve the competitiveness of Peru's foreign trade, through reduce congestion in the port of El Callao, increase total cargo handling capacity, improve logistics connectivity, and attract investment. The results are expected to be strengthen the country's logistics infrastructure, reduce transportation costs, and promote regional economic development, generating employment, and increasing efficiency in the handling of goods. It includes the railway project between the Port of Callao and the Port of Shanghai, which is a key initiative to improve transport infrastructure in the region, impacting the economy of the entire region between Lima and Barranca. The Interport Railway uses the infrastructure of the Lima-Barranca Railway, which will benefit more than 4.5 million people. The railway will boost international and regional trade, increase logistics efficiency, and generate employment, both in the construction and operation of the railway. Its construction involves significant investment that is being driven by the public and private sectors, including the participation of foreign companies in financing and construction. The railway is part of the Peruvian government's efforts to modernize its transportation infrastructure and increase the country's competitiveness in global trade. Cities and regions, analytical, smart and sustainable. High RPO, Regional Planning Optimization, is a set of predictive and prescriptive artificial intelligence mathematical models to support the planning of regions formed by urban and rural areas, with a high degree of integration. The mathematical programming models aim to guarantee the intelligent and sustainable characteristics of large conurbation regions, which is not easy, given the high complexity involved in its management. The core model of regional planning is presented in the book Designing and Optimizing Networks for Smart Cities and corresponds to Chapter 1. A mathematical programming model for regional planning that incorporates economics, logistics, infrastructure, and land use. The book Regional Planning, Cities and Regions, Smart, Autonomous, Analytical, Integrated and Sustainable, is the course guide. The artificial brain is the evolution of decision support systems under Industry 4.0. It is conceptualized as a set of mathematical models, which exchange information autonomously with each other, working online using distributed optimization. The diagram presents some of the models that make up the artificial hypothalamus of a regional planning system. In the case of regional planning, an example of the physical systems associated with autonomous, real-time optimization models that communicate with each other are inhabitants, installations or equipment, energy, land use, companies and industries, and transport and logistics. Integrated planning of the region. Regional modeling is a planning tool based on a system of mathematical models of different types of optimization, econometrics, computable equilibrium, etc., integrated to determine the business structure and the development of the population that would exist if certain socio-economic development objectives were met. The hierarchical system for decision-making is the first step in the definition of an artificial hypothalamus of regional planning. Its structuring must consider two aspects. Time, related to the transcendence of decisions. 3 levels of planning are typically used: strategic, tactical, and operational, or in other words, long-term, medium-term, and short-term planning. Space, related to the coverage of decisions in space. This structure does not have a defined axis and therefore depends on a specific reference framework for each region. It is closely linked to the planning instruments defined in the Land Use Plan. The master plans for the development of social infrastructure are aimed at determining the way in which the supply should be organized, to meet the demand in the different facilities, for example, schools, hospitals, health centers, marketplaces, entertainment centers, etc. In regional planning, mathematical models should be considered to support the following master plans: high-impact facilities, ports, airports, academic facilities, schools, universities, health centers, hospitals, emergency centers, solid waste treatment, public space, shopping and social centers, and special facilities, social development centers, libraries. All subsystems are integrated into a single mathematical model, to optimize the holistic development of the region and describe how the region would evolve from the boundary condition in the initial period, to the end of the planning period. This, taking as a reference the parameterization of the territorial planning policy. The model describes the dynamic evolution of multiple variables that serve as indicators of the development of the territory. Some variables are predominant use, area occupied by housing, public space, industry, equipment, roads, density, land available, and so on. New means of visualization, such as those offered by LuxCarta, allow the results to be visualized through digital twins, which accelerates the understanding of what the territorial model analyzes. Quantitative simulation of port-region interaction. Its objective is to evaluate the quantitative impact, in multiple dimensions, of action scenarios associated with different public policies. It is carried out through the enterprise-wide optimization system, regional planning including port systems. The model is aimed at evaluating, and helping to solve, the main problems facing the port, and that the region faces. It can be used as a simulation model, to evaluate scenarios, or as an optimization model to determine the optimal scenario. The latter is what produces the greatest wealth for society. Drayage or the container hauling problem. It is one of the problems generated by the interaction between the port and the region, since, in many cases, its impact is traffic congestion in the region, and possible congestion in the ports. Drayage is the transportation of cargo over short distances of 50 miles or less. They often range from an ocean port to the first inland destination, which could be a rail yard, warehouse, or other stop before their next destination. It makes intermodal transport more efficient, allowing the smooth transfer of goods to the end consumer. You may also hear that the carry is referred to as the first mile. The ISO container distribution and/or pickup issue, 20 and 40 feet, is a variant of the vehicle routing issues with multi-stop backhauls, VRPB, where a truck visits multiple nodes until returning to the terminal. Loaded containers arriving at the terminal, import inbound containers, or empty containers from the terminal depot, must be delivered to customers, and loaded containers, export outbound containers, as well as empty containers, must be picked up at customers' premises and transported back to the terminal. Therefore, when towing trucks, the combined chassis combination possibilities include all feasible combinations of containers, 20 feet and 40 feet, that need to be transported to or from the terminal and customers. There are several possible matches, and it is worth choosing those that result in a route of minimum distance, or minimum time or cost, or a weighted combination of the above. Optimal location of port and extraport facilities. For the port to function properly, and for the region that gives it space, to capture the social benefit generated by the port, it is necessary to have a holistic vision of port and extra-port facilities and foresee how the integral system will work. A deficit of facilities at the port will generate congestion in the region, by exploiting its internal problems to the region, for example, queues at the port that generate queues of trucks on the streets. A deficit of facilities outside the port will lead to congestion in the region, which may spread to neighboring regions. For example, these extra port facilities are hotels, parking lots, processing offices, road capacity, and others. Therefore, when planning a megaport system, you need to look precisely, inside and outside the port. Given the high dimensionality of the problem, this can only be done correctly, with a highly complex mathematical model. The problem is complicated when the port system contemplates the interaction between multiple ports. But there is always a solution. To use the POT model for special infrastructure projects, such as ports and airports, models representing these systems must be included in the artificial hypothalamus. Optimization of the port system and regional planning. High port optimization, is integrated with high HRPO, holistic regional planning optimization. This implies that all models of the two enterprise-wide optimization, EWOS, systems can be integrated through the database, an expert optimization system, using a common data model, and/or through equations that integrate a single holistic model, all this following the principles of structured mathematical modeling. High port corresponds to an aggregate model of port operations, and the high HRPO must include the port system as individualized but connected facilities. In general terms, there are two alternatives to perform the simultaneous optimization of the two systems. Coordinated optimization of the port system and regional planning, through a mathematical conversation between them. Integrated optimization of the port system and regional planning. Generate an integrated model, which can be solved monolithically, or using large-scale optimization methodologies. Maximizing social surplus. Following the fundamental principles of Walrasian general equilibrium theory, the problem of obtaining the optimal allocation of land use is to find the allocation that maximizes the social surplus that the region can produce, in such a way as to ensure the efficient use of all resources. From the point of view of the regional government, since it controls only a part of the social surplus, which is derived from its decisions, therefore, in free regimes it can only indirectly try to maximize a part of that surplus. Another part is out of your control. Considering that the supply and demand functions of goods and services found in the market are not available, it is necessary to use the technical economic model of territorial planning, POT, to estimate the social surplus generated. An alternative is to maximize partial wealth with respect to the resources used in the POT. This considers the consumption of resources required and the costs and benefits generated using these resources. The screenshot shows the OpText Results Explorer, from which you can view all the input-output information of a mathematical model run. In this case, the table associated with the variable occupied area is presented. Like Herbert Simon, Hypothalamus AI believes that the computer-based mathematical modeling is the greatest invention of all times. Thank you for your attention.